Hey guys, it's Miss A again. Today our video is going to go over how to convert fractions into decimals. Before we get started, let's go over a few vocabulary words. The first word is a repeating decimal. Repeating decimal is a decimal with an ending digit or group of digits that repeats. So that looks like 0.333333 ... or 0.232323 ... Those dots represent that it's going to keep on going. But in math, we don't want to have to write the number multiple times. We don't want to have to write those dots. So we put this little symbol, 0.3, a little repeating bar on top. So anytime you see a bar on top of a number, it's showing you that the number underneath it repeats. So for this one, we would put 0.23, and we put a bar on top of both of the numbers together because they both are repeating. And the second word is terminating decimal. A terminating decimal is a decimal that comes to an end. 0.5 just stops, 0.75 stops. Now let's get into how we actually convert a fraction into a decimal. The first thing we need to recognize is that a fraction bar is a symbol that actually represents division. So when we have the fraction 3/4, that is literally saying to divide 3 by 4. The fraction bar literally says to divide. That's a symbol to represent division. And here are 3 ways to help you remember how to set up your division problem when we're converting a fraction into a decimal. You can choose the one that you like the best. I'm always probably going to go back to Tybo, but if you like FISO or Cowboy, like if you like drawing, then choose any one you like the best. Alright, so Tybo actually stands for top, in, bottom, out. So what that means is that if we have a fraction 3/4, remember that the fraction bar means division, so we're going to set up a division problem. And by default, you always want to put the bigger number on the inside, because that's what you're used to doing when you first learn division. But that's not always the case anymore. So we need to remember this little acronym, top, in, bottom, out. So the top number is going to go inside, the top number being 3, and the bottom number goes on the outside. And that's how we would set up the division problem. And I'll show you how to divide that here in a couple minutes. The second one that I actually came up with a couple years ago, like I didn't come up with Tybo, but I did come up with FISO, stands for first, in, second, out. And the reason I came up with this one is because sometimes when we're on a computer or something, we have to write a fraction that looks like this, 3-4, but that still is representing a fraction and it still represents division. But there's no top and bottom here. They're side by side. So knowing FISO, if we set up our division problem, the first number goes inside and the second number goes on the outside. It also works for a regular fraction like this. The first number being 3 would go on the inside, the second number being 4 goes on the outside. And the last one is the Cowboy method. It's kind of silly. If we have the fraction 3/4 and we were just to make it into a picture of a cowboy on a horse, I could draw some legs like this, the neck, there's his head, his mane, or whatever that's called in a horse, his tail, and then the cowboy on top has a little hat. So now we have our cowboy riding on top of the horse. If we think of it in terms of the division being a house, the division bar being a house, the cowboy goes inside the house or inside the barn, and the horse has to stay on the outside. Notice they're all set up the same exact way. You can choose which way you like the best. I'm always going to go back to Tybo. Alright, let's get into some examples. Number 1 says to convert 3/8 into a decimal. So again, I'm going to remember Tybo, top in, bottom out. So the first thing I'm going to do is set up my division problem. And I'm going to put the top number inside and the bottom number on the outside. Let me see if I can zoom in just a little bit. So it's... There we go. Focus it. Alright, we're good. Alright, so we're going to do Tybo. Top number goes in, so 3 goes in, and the bottom number goes on the outside. And now I'm going to start dividing. So the first thing you realize is that 8 cannot go into 3, so we're going to put a 0. Then we're going to add a decimal and a 0. Now the reason I add a decimal first is because I don't want to change the problem. If I just put a 0, my problem becomes 30 divided by 8, but putting a 0.0 keeps it 3. 3 is equal to 3.0. So now I can do the division, goes in 3 times, which is 24. Do my subtraction, this is basic division. We have to borrow, that becomes a 10, that becomes a 2. 8 goes into 60, 7 times. If we get a remainder, we have to keep on going. So we have 56, subtract 4, still got a remainder, add a 0. And then 8 goes into 45 times. Alright, and once I get a remainder of 0, I can stop. So my decimal equivalent of 3/8 is 0.375. Or 375 thousandths. Alright, number 2 says to convert 3/5 into a decimal. So again, we're going to set up our division problem. Top in, bottom out. Top in, bottom out. 5 cannot go into 3, so we put a 0. And don't forget to put your decimal first and then add your 0. Drag the decimal up. Remember, we don't want to change the problem, so putting a decimal and a 0 keeps it the same. 5 goes into 30 6 times, which is 30. Subtract, we get 0. And that's it. Once you get a remainder of 0 and there's nothing else to bring down, your problem is done. So 3/5 is equivalent to 0.6 or 6/10. Alright, number 3 says to convert 2/18 into a decimal. So one thing I would do here, because my denominator is 18, I don't know my multiples of 18, so when I'm dividing, it would be a little bit tricky. So what I'm going to do first is I'm going to reduce it. I'm going to simplify it by 2 over 2 because it has a common factor of 2. 2 divided by 2 gets me 1. And then 18 divided by 2 gets me 9. And now I can go into my division. Top in, bottom out. 9 can't go into 1. Put a decimal and a 0, decimal up. 9 goes into 10 one time. Subtract, you get 1. Add a 0. 9 goes into 10 one time. Well, you notice here I keep getting a remainder of 1. 9 goes into 10 one time. And I'm also repeating the same digit up here on the top. So at that point, I'm allowed to stop. I would put 0.1, and don't forget your repeating bar. So that 1/9 or 2/18 is equivalent to 0.1 repeating. Alright, one last example together. We've got convert 3 and 2/6 into a decimal. So this is a mixed number. Don't let that part confuse you. You know that this is a whole number, and you need to remember that whole numbers go before the decimal. So I know whatever my decimal is, I'm going to have a 3 in front of it because that's the whole number. So before I go into my division, though, I'm going to reduce this fraction because 2/6 can be simplified, so I might as well do it. So I'm going to reduce it by 2 over 2. 2 divided by 2 gets me 1. 6 divided by 2 gets me 3. And then my whole number was 3, so that goes in front of my fraction. So now my fraction that I'm converting, it's still equivalent to 3 and 2/6, but it's now 3 and 1/3. So my whole number went in front of my decimal. Sorry, the light in my room went off. Now I'm going to convert or change 1/3. So top in, bottom out. 3 cannot go into 1, so we put a decimal and a 0. Drag the decimal up. And then 3 goes into 10 3 times, which is 9. Subtract, we get 1. Add another 0. 3 goes into 10 3 times, which is 9. Subtract, we get 1. So you notice we keep getting a remainder of 1 here, and we keep putting the 3 on the top. So I'm allowed to stop. My decimal is not 0.3 repeating, because I had a whole number of 3. It's 3.3 with the bar on top of this 3. 3.3 repeating is the equivalent decimal of 3 and 2/6. Alright, So if you need to go back over these examples one more time, if you need to watch them again, that's perfectly fine. Feel free to do so. But we're going to do a couple examples on our own. So if you will take the time, write these two fractions down, pause the video, solve them on your own, and we'll come back together in just a minute and we'll see if you got them correct. So go ahead and pause the video and we'll come right back. Alright, now that we're back, let's check your work and see if you got them correct. So the first one was 5/8. So you should have set up your division problem, top in, bottom out. And then you see that 8 cannot go into 5, so you should have put a 0 on top, and then added a decimal and a 0, and then bring your decimal up. 8 goes into 50 6 times, which is 48. When you subtracted, you should have got 2. Got a remainder, so you add another 0. 8 goes into 20 2 times, which is 16. Subtract, you got 4. Still got a remainder, so you had to keep on going. Add another 0. 8 goes into 45 times, which is 40. So you got a remainder of 0, so now you're allowed to stop. So 5/8 was equivalent to 0.625, or 625 thousandths. And the last one was 2/3. So you should have Taibode, FISO, Cowboy method, whatever you chose. Top number goes inside, bottom number goes on the outside. 3 cannot go into 2, so you put a 0. Add a decimal and a 0. Remember, we put the decimal because we don't want to change the division problem. So 2.0 keeps it 2. Now we look at 3 goes into 20. What is that? 6 times, which is 18. Subtract, you get 2. Add a 0. 3 goes into 20 6 times, which is 18. Subtract, you get 2. So you notice we got a remainder of 2, and our numbers up here are repeating. So we can stop. My decimal equivalent is 0.6 repeating. Do not forget the repeating bar, or else it is wrong. Alright, so that is how you convert a fraction into a decimal. Remember that the fraction bar means division. You can do top in, bottom out, first in, second out, or use the cowboy method. It's totally up to you, whichever way you prefer. If you need to, rewatch this video. Hope it helped. Y'all have a great day. Bye.